Hello everyone, this is N. Kavita, working as Assistant Professor in Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. Today we are going to see a topic on programmable array logic and programmable logic array. What is this PAL and PLA in short? So generally, earlier it was a logical circuits has been designed using your small scale integration components like logic gates, multiplexers, demultiplexers, flip-flops, etc. Now, the programmable logic devices can replace all the small-scale integration components. A programmable logical device may be classified into many different categories. It is a kind of chip which is used to implement your logic circuit. It includes a set of logic circuit elements which you can able to modify in several ways. PLD is nothing but it consists of a programmable switches as well as the logic gates. Since there are many programmable switches and logic gates, you can able to program your own devices. So, both the programmable array logic and programmable logic array are nothing but the types of the PLDs. What is PLD? It is a programmable logic device. There are few differences between the PAL and PLA design, which we are about to see in the further slides. The main difference among these two is that this PAL can be designed with a collection of AND gates and fixed collection of OR gates. Whereas in case of programmable logic array, you can able to design with a programmable array of AND gates. Also, it contains a fixed collection of OR gate. So we will see in the further slides. Take it in short. So you assume this to be a programmable array logic, a PAL circuit, where n number of inputs are present and there are one programmable AND gate, whereas the OR gate is going to be the fixed part. So we can able to customize or we can able to program only the AND. And finally, the fixed OR gate will produce the output. Similarly, we have the logic diagram or a block diagram for programmable logic array. Here we have got n inputs. In this specific category, both the AND gate and OR gate are programmable. Whereas in case of programmable array logic, only the AND array is able to be programmable and the OR arrays are always fixed. So, this is the basic difference. With this, we can move forward for the design of programmable array logic. The designing of programmable array logic can be done with the help of fixed OR gates as well as programmable AND gates, as I have given you already. We are going to see with an example of implementing the Boolean function. These are the Boolean function which we are going to design with the help of programmable array logic. When you observe these two Boolean expressions, x is equal to ab plus ac complement, y is equal to ab complement plus bc complement. So it is very obvious that the provided Boolean function is an SOP. Hope you know what is SOP. It is sum of products. I have got a product term AB. I have summed it. Again, there is a product term. And that is why it is called sum of products. So these product terms in the Boolean expressions are represented by the variables x and y. And we have got one product terms in this comment. When you observe this, you can find out the specific variable a, which is over common in many part, and c dash is common in these two Boolean equations. So before getting into the construction part of PAL, we are supposed to identify how many number of AND gates and how many number of OR gates are required to design this specific Boolean function. When you check out here, x is equal to AB, this is one product term. AC complement is the other product term. AB complement is the third product term. BC complement is the fourth product term. So to design these four product terms, we are in demand of acquiring AND gate. So the products are always constructed using AND gate. I'll give you an example. For example, if it is a 2-input AND gate, we can make it as this is your input A and this is your input B, and definitely this is my output, which is AB. Likewise, we are in need of categorizing 4 AND gate to make this operation. Fine. And now The given Boolean expression contains sum of product terms, which means X requires an OR gate and Y requires a OR gate. It is very clear from the Boolean expression. You can see over here, it has a expression X is equal to AB plus, so one sum term is required. Followed by that, you have got the other sum term AB complement plus BC complement. So it is very evident that here we require two OR gates, that is two OR programmable gates are required. When we get into this equivalent PA logic diagram, it is going to be the very simple logic. Here you have got the AND gates and OR gates, which together will form the programmable array logic. Before getting into it, you must know the importance of having the input array. An array is nothing but it is a collection of logical gates. You can observe here from the expression, it is very evident X is equal to a certain expression is provided. So before getting into the expression, you can just observe I have given three inputs A, B, C, and finally I have got many outputs from the OR gate. And now we can get back with this expressions. When you observe here, this is a A, this is a inverted form of A, this is B, this is inverted form of B, this is C, and this is inverted form of C. When you observe here, we have got one expression for X, which is nothing but AB plus AC complement. So I have taken A over here, I have taken B over here, it is provided to the AND gate, hence AB. The next term is AC dash. Similarly, I have taken an input from A, I have taken an input from the inverted form of C, which indicates C complement, AC complement. Similarly, we have an expression for Y, which is A B dash plus B C dash. So when you make this equation, similarly A and B complement, we have a product term. And the last is BC dash. So I'm marking over B here and the inverted form of C, it is taken over here and we have obtained BC complement. So from this it is very evident that with the help of the Boolean expression we have taken four programmable AND gates. And how to take the OR gates. So OR gates is very simple. We have to make an OR operation of two things. One is called AB plus AC complement, which is missed out here. I'll mark it. So I'll have a AB and I'll have this AC component. So this together will form this is an OR gate. So this AB plus AC complement will provide the output X, whereas in case of Y, I have to mark over here AB complement and BC complement, and this will provide the output Y. So it is very simple. This programmable array logic where you can able to have the four different AND gates, which is considered to be the programmable part. Right. So when you look onto this programmable array logic here, I cannot able to program the OR gate. I can able to program only the AND gate. Right. So whenever these two conditions are true, it takes the input as X. Whenever these two conditions are true, it takes the output as Y. Whereas I cannot able to program the OR gate because the OR gate is going to be the fixed part in case of programmable array logic. The next thing is programmable logic array. When you look into the programmable logic array, it is similar to that of the programmable array logic. One small difference is that here both the AND gate and OR gate are going to be the programmable part. When you look this Boolean expression, I have given X is equal to AB plus AC component. Again, this expression is a sum of product expression where X and Y are considered to be the product terms in the Boolean expression. When you observe this, it has two product terms. When you observe the equation Y, it has three product terms. But make a close observation. Here, one parameter or one product term is exactly one and same in X and Y. Hope you can guess what is the term. It is AC complement. So this AC complement term is common in case of X as well as in case of Y. So I can make it as, I can cut off it as either in anywhere in 1. So the total number of AND gate which is required to design the circuit is 4. because when you design the same AND gate for the same variable again, the memory consumption is going to be high, and the space of the logical components of the gates which you are going to use is also increased. So I am reducing it. And again, we have got the OR gates, and we have got the programmable OR gates because I have neglected this term. So in such a case, we have got two OR gates. Please look into this programmable logic array so that it is very clear to you. Here we have got the same expressions like AB, AC complement, AB dash, BC complement, etc. So what is the expression which we have got for X is, it is AB plus AC complement. This is the expression for X. And what is the expression we have got for Y is AB dash plus BC dash plus again there's a common term AC dash. When you observe here, I have programmed both the AND gate as well as the OR gate. Observe it. Here we have got A, we have got an inverted form of A, B, inverted B, C, inverted C, and this is an AND gate which is programmable, which is similar in case of PLA. I have marked for A, I have marked for B so that it becomes AB. Similarly for A, and I have marked for AC complement, it goes with that simultaneously for all the four product terms. When you observe here, the one major difference is I have programmed my OR gate session, which doesn't happen in the programmable array logic. The programmable array logic, it will take the input for X and Y expressions if all the conditions are true. But here in case of programmable logic array, I can able to program my device. For example, if X is equal to AB plus AC complement, I have marked over AB here, I have marked over AC here, and this becomes the output X. And again, in case of Y, AC complement, AB complement, BC complement, when I R all these three, I'll get the output Y. Hope the difference is clear to you. In case of PAL and PLA, the basic difference is that in case of PLA, both AND and OR gate array are programmable, whereas in case of programmable array logic, only the AND gate array is programmable. We will have a quick review in difference between these two PAL and PLA. So the construction can be done with the collection of AND gate and OR gate in case of programmable array logic, whereas in case of PLA, it can be done by collection of AND gate, but here the OR gates are fixed. In PAL, it is more flexible to make your programs when compared to PLA. In PLA, the flexibility is less comparatively. The cost of PAL is very expensive, whereas in case of PLA, it is very middle range. Number of functions implemented in PAL is large. The number of functions implemented in PLA will be limited. The speed of PAL is slow, whereas the speed of PLA will be high. So these are the basic difference between PAL and PLA circuits. Hope this video is helpful to you.